A very good evening to all of you. So today we are going to understand the preset and the clear input. So why we are requiring this preset and the clear input? Suppose if you want to set the flip-flop before applying any clock pulse, then this preset, that is preset, you are setting the flip-flop output as 1 before applying any clock pulse. Fine. Then in that case, preset will be used. Now suppose if you want to clear the output before arrival of any clock pulse, then this clear input will be there. So basically these are the asynchronous input and they are independent of the clock pulse. Like you can see here, this S and the R, they are synchronous input. So this become activated only on the arrival of the clock pulse. Fine. Now one more thing which you want to note, that this preset and clear are the asynchronous input and they are active low inputs. It means that the output will respond only when you are applying the active low signal to the preset and the clear. Fine. Now we'll just test the concept. Now suppose if you're applying a logic 0, then what is going to happen? You can see here, this is the NAND gate, and if one of the input of the NAND gate is 0, then the output has to be 1. Fine. So when Qn will be equal to 1, then Qn bar will be equal to 0, because these are complementary outputs. So now you can see that the output has become to logic 1. Even you can see the no clock pulses has been applied, but still your output is 1. So that is presetting your flip-flop. Now similarly, you can reset your flip-flop even if you are not applying any clock pulse, even if you are not applied any clock pulse. Then how it can be done? Just simply, these are the active low input. You just have to place a logic 0 on the clear input. That is, after placing a logic 0, then what is going to happen? This one will become 1 straight away. Fine. Now this is 1 and this one will be equals to 0. Fine. So you can see here, you have not applied any clock pulse, still your output has become 0. So these are the asynchronous input and they are independent of any clock pulse. Fine. Now we are going to understand the truth table. Now suppose if someone asks, so what is going to happen if you apply a logic 0 and logic 0? These are active inputs, these are active low input. So this will become 1 and this is not possible. I think 1 has to be, these both outputs are complementary. 1 it is not possible, so this is not going to be used. Fine. It means that at a time only one input should be made active low. You cannot make both the input as active low. Fine. Now what is going to happen if you provide 1 1 to it? So suppose if you are providing 1 1, then you will have to wait for the clock pulse, because then this will act as a normal flip-flop. Fine, this one is 1 and this one is 1. So you cannot make any decision depending upon these two input. So that's why the preset and the clear are active low inputs. So we can see here the analysis has been done. This is the preset and the clear. 0 0 not applicable. This is the invalid state. Then 0 1 active low input is at the preset. If it means that you have to set the flip-flop. Now similarly, the clear active low is at the clear input. It means that you will have to clear the flip-flop. And when 1 1, it means normal flip-flop. So this is a truth table which you need to remember for your future applications. So fine. This is all about the preset and the clear input. So if you're having any doubt, you can comment and we'll meet in the next class. Thanks a lot for today's session.